All right, good morning, guys. I know it's been a while since some of you have probably heard my voice, but I'm glad for us to kind of be back and getting into our own groove. So the first assignment that I have for you guys is just going back to what we did before all of this craziness started, and we're going to be adding scientific notation. We're going to do a day of little notes like this worksheet, and then tomorrow you're going to have a quizzes on adding scientific notation as well. So all of the steps are here. I'm not going to read those for you, but we can go ahead and get started on number one. If you don't have a printer at home and do not want to print this out, it is perfectly fine. You can do it on a piece of notebook paper and just write the problems down and do them while we're doing them as well. All right, so the first thing that you need to do is convert these to standard form. So we're going to move, sorry, I'm getting used to writing and videoing all at the same time. So we're gonna need to move the decimal 5 to the right. So 1, 2, 3, 4, 5. And in those 4 blank spaces, we have 1, 2, 3, 4 zeros. Then we're gonna do the same thing over here. We're gonna move this decimal 5 to the right. 1, 2, 3, 4, 5. We have 3 blanks, so 3 zeros. So then we end up having the number 550,000. So we're gonna write that first. Use your commas, it will help you. And then just kind of make sure that your number matches what you had. So you had 5, 5, and 1, 2, 3, 4 zeros. 5, 5, 1, 2, 3, 4 zeros. So same number. Plus, now remember, you got to have place value. So you got to start with your 1. You're lining up based on your 1's place. So from the right. So you have 1, 2, 3 zeros. 1, 2, 3 zeros. 3, 2, 6. So 550,000 plus 623,000. So start from the 1's place. 0 plus 0 is 0. 0, 0. 0 plus 3 is 3. 5 plus 2 is 7. 6 plus 5 is 11. So your answer is 1,173,000. So it's all correct. However, we also need to make sure that we write our answers in scientific notation. So remember the song, we have to have a number between 1 and 10. So you're going to place your decimal somewhere that creates a number that's a 1 or bigger, but it has to be less than 10. So we can't put it here because that'd be 117.3. We can't put it here because that'd be 11.73. So, and that's a bit too big. So we have to put our decimal here. This is going to be our first number. So 1.173. Multiplication always comes next, so times 10. And then you have to have your exponent. So our original exponent was back here, or our original decimal was back here, and we moved it to here. So it moved 1, 2, 3, 4, 5, 6 times. So our exponent is 6. And the last thing you have to ask yourself is this going to be a number, or a positive exponent or a negative exponent? Because this is a large number, we're going to keep it positive. So this is your final answer. Okay, so now I would like all of you to go ahead and pause this video, and I want you to try number 2 on your own. All right, so hopefully that was enough time. If not, you go ahead and continue pausing. All right, so once again, we need to move our decimal 5 to the right. So 1, 2, 3, 4, 5. Don't forget the 6 is in this space, so that's 1, 2, 3, 4 zeros. So that's going to be 460,000. This exponent means we need to move the decimal 7 to the right. 1, 2, 3, 4, 5, 6, 7. That'll be 5 zeros. 1, 2, 3, 4, 5. So this is a much larger number. It's going to be 11,200,000. So when you line these up, this number is going to be shorter than this one. So just make sure you line up from the right side, your ones place. So you have 460,000 plus, remember, got to line up from the ones place. So you got to start from the right. There's 1, 2, 3 zeros, 2 zeros and a 2, and then 11. And then you add like normal, 0, 0, 0, 0, 6, 4, and 2 make 6, and 1 and 1. So your answer is 11,660,000. So remember, the last thing that you have to do is write this number in scientific notation. So you got to start with a number between 1 and 10. You're always going to put it here right after that first place value, because if not, it'll be 2 digits, which will be bigger than 10. So we can't have that. So we need this whole first number, 1.166. Next thing is always times 10. And then you have to figure out your decimal. It was here. So then you just count 1, 2, 3, 4, 5, 6, 7. And it's a very large number. 11,660,000 is a really big number, so that's going to stay positive. All right, so go ahead. You try number 3. I'll give you a little bit of time, but if you need to pause, go ahead and pause. All right, so for this problem, the biggest thing that you have to remember is to put your decimal in the right spot. So these are whole numbers, so don't put your decimal to the left. 0.7 is not equal to 7. We need 7 and then your decimal to the right, 5 and then your decimal to the right. So you move your decimal 6 times. 1, 2, 3, 4, 5, 6. So that means you're going to have 6 zeros. So this number is 7 million. Plus, this one's going to be smaller because you only move it 4 to the right. 1, 2, 3, 4. 7 million plus 50,000. Do not put that 5 under the 7. You're not adding your place value correctly. So you got to put your ones place on top of your ones place. So it'll be 1, 2, 3, and 50,000 like this. So 7 million plus 50,000. I think a lot of you can probably do this in your head. If not, just add like normal. So 7 million and 50,000. So this problem was pretty easy as long as you know where that your decimal goes to the right. If you got 700,000 plus 5,000, you started with your decimal to the left. Remember, we need a number bigger than 1 or bigger, so it has to go to the right. All right, and last step, we're going to write this number in scientific notation. Always put your decimal after the first digit so it's equal to or greater than 1, but less than 10. And remember, you have to include all of your numbers that aren't 0. So if you left off this 5, you're leaving off 50,000, which is a lot. So we need to make sure we include that 5. So your first number is 7.05 times 10, always comes next. And then you figure out how many times did your decimal move. It started here, so it moved 1, 2, 3, 4, 5, 6 times. And then once again, you can always check to make sure that your numbers or your scientific notation is equivalent to your standard form, because you can move this 1, 2, 3, 4, 5, 6, and your answer would be 7,050,000. So it would match. All right, let's go ahead and move on to the other side. Let's see if I can get this lined up a little bit better. I don't know if that's any better at all, but I can try. All right, so this time around, we're still adding numbers in scientific notation, except these are going to be really small numbers. These exponents are negative, so that means we've got to move our decimal to the left. So we're going to start here and move it 1, 2, 3, 4. Big thing to remember is we're moving the decimal, so our decimal is now all the way to the left. And we had 1, 2, 3 zeros. So our first number is 0.00046. Plus, and we're gonna do the same thing here. 1, 2, 3, 4. My decimal's in front now. And I have 1, 2, 3 blanks. So for this time around, when you're adding decimals, a lot of you know that you're supposed to line up your decimals, but that is because of place value. So your tenths place, your hundredths place, your thousandths place, 10,000s, 100,000s, and so on, all have to be lined up on top of each other. Okay, you still start from the right side when you're adding. So 0 plus 2 is 0. I mean, no, that's a lie. 0 plus 2 is 2. 6 plus 1 is 7. 4 plus 1 is 5. 0, 0, 0, decimal. So this is your final answer. However, we know we have to write it in scientific notation, so same thing goes even for really small numbers. You're trying to get a number between 1 and 10. So if it's here, 0.572 is too small. If we put it here, 57.2 is way too big. It's bigger than 10, so it has to go after that first number. So my first number is 5.72. Times 10 is always next. And then once again, you count from decimal to decimal. We moved it 1, 2, 3, 4 times. But because this is a really small number, we have to make our exponent negative. If I were to take this decimal and move left, that would give me the number, my answer. If I left it positive, it would move right and it would be way too big. So here is your final answer. Okay, so you go ahead. Try number 5. Go ahead and pause this video. I think I'm gonna go ahead and move on, but go ahead and pause it here so you guys get a chance to do it on your own. Because if you're just copying me, then you're really not learning anything. But let's go ahead. So this time, remember, we're gonna move our decimal 5 left. Same thing, 5 left. 1, 2, 3, 4, 5. Remember, your decimal is in front. Do not leave that decimal here. You have 1, 2, 3, 4 zeros. 0.1. All right, so last video cut out on me. So we're going to get back to problem number 5. And we're gonna finish 5 and 6. So this second video should be pretty short. All right, so we moved the decimal 5 left. So our number was 0.0000, 1, 2, 3, 4 zeros, 3 and 5. And you can always check and make sure 1, 2, 3, 4, 5 plus this one's gonna go 5 left, 1, 2, 3, 4, 5. Remember your decimals all the way in front. 1, 2, 3, 4 zeros. Remember to line your decimals up and make sure each one of those place values are perfectly on top of the other. This one's pretty easy because everything's lined up. So 5 and 9 makes 14. Bring down your 4, bring up your 1. 7 and 3 is 10, plus 1 is 11. Bring down your 1, bring up your 1. 1, 0, 0, 0. So that's your final answer. Except we need to write it in scientific notation. So create a number between 1 and 10. You can't put it here because that's 114. You can't put it here because it's 11.4. So you're gonna have to move it here. So this is your very first number, 1.14 times 10 is always next. And then you're gonna count from decimal to decimal. This is where it was, this is where you moved it to. 1, 2, 3, 4. If I keep it positive, then we would move this decimal 4 to the right, which is going to create a very large number. We have a very small number, so you have to make sure your exponent's negative because we need to move that decimal 4 left to get this answer. So this is your final answer. All right, so go ahead and pause this video so you can have a chance to do number 6. I'm gonna go ahead and get started on it, but make sure you pause it. All right, so the biggest mistake with these is you're gonna start with your decimal to the left, but 0.6 is not between 1 and 6, or my bad, 1 and 10. So you need to make sure it's a whole number. You're putting your decimal to the right. This exponent tells you to move 7 times to the right. So 1, 2, 3, 4, 5, 6, 7. It's gonna be 7 zeros. So 1, 2, 3, comma, 1, 2, 3, comma. That's gonna be, no, that can't be it. 1, 2, 3, comma, 1, 2, 3, comma. That's gonna be 60 million. Plus, this number is going to be bigger, so make sure you leave a little bit of space. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 1, 2, 3, 1, 2. So this is going to be 400 million. Make sure you line your numbers up based on the ones place. 1, 2, 3, 4, 5, 6, 7, 8. I just realized I meant for this example to have a negative exponent, but it is okay. It's all good practice. Go ahead and add them up. So your answer should be 460 million. Remember, no matter if it's a really small number or a really large number in your answer, we have to create a number between 1 and 10, and it is always going to go after that first number, like up here and here. So our first number is 4.6 times 10 is always next. And then this is where we moved our decimal to. It was originally here. 1, 2, 3, 4, 5, 6, 7, 8. Now this is a really large number. 460 million is huge. So we want to keep that exponent positive. So that is our last and final answer. So hopefully these examples helped you out. Tomorrow there is a quizzes that you can find on my website that will go over, I believe there's 8 problems, and you will have some that have positive exponents. You can have some that are negative exponents, but they're all adding in scientific notation. You have unlimited amount of times to do it, and it's all going to be examples like this. So you can have this in front of you or have this video off to the side, and you can have this as a guide or notes or help. So hopefully you don't have any questions anymore, and good luck.